From the Lean Enterprise Institute in Boston, this is the WLEI podcast, where we share stories of people making the world better through lean thinking and practice. For more information about LEI, including how we can help you apply lean thinking, please visit lean.org.
Welcome to the WLEI podcast. I'm your host, Matt Savis. Please excuse my terrible voice here. I'm getting over a bit of a cold and I sound terrible, but I'm feeling okay. With that out of the way, I'm excited to bring you a really thoughtful discussion on the state of manufacturing in the United States. I have two wonderful guests, Ben Armstrong from MIT's Industrial Performance Center, he's their executive director, and Jim Morgan, a senior advisor with the Lean Enterprise Institute who has decades of experience in the automotive industry. They'll be sharing perspectives from Ben's extensive research on the history and future of U.S. manufacturing, as well as Jim's firsthand knowledge of developing new products and production processes. We're going to explore topics like the rise and decline of America's manufacturing expertise, the challenges of reindustrializing, the consequences of lost know-how, particularly to China, and then we close with the impact of new technologies going forward. I hope you enjoy this conversation as much as I did. Note that this episode is part of LEI's Design Brief series, where we discuss principles and practices of lean product and process development, otherwise known as LPPD. This month we're featuring a series on the importance of great process engineering, like tool, mold, and fixture making, or special machine design. Anything that goes into knowing how to make things well. You can subscribe to the newsletter through the link in the show notes. Let's get started. Jim and Ben, welcome to the podcast.
Yeah, my pleasure.
Thank you.
All right, we always start these things by giving our audience a sense of who our guests are. So I'm going to ask you both to just offer a brief introduction to yourselves. I'll start with Ben.
Yes, I'm Ben Armstrong. I'm the executive director of MIT's Industrial Performance Center, where my research focuses primarily on U.S. manufacturing competitiveness, the ways that American manufacturers adopt new technology, recruit new workers into manufacturing, and also how manufacturing has evolved historically. The rise of U.S. manufacturing in the late 19th and early 20th centuries, and the decline for the last 4 or so decades. So I'm very excited to be here and to be talking with you, Matt and Jim.
Thanks, Ben. And Jim.
Jim Morgan. I'm a senior advisor at the Lean Enterprise Institute. I'm an automotive industry guy. I worked at Ford. I worked at Rivian. Super excited to engage in this discussion with Ben.
All right. Well, just to frame this conversation up a bit, this is part of a series that LEI is publishing around, we're saying, making things well. And when we say making things well, we're talking about process development, tooling, fabrication, the idea of taking a design and building it for the customer. And Ben, as the co-lead of MIT's Future of Work initiative, you have a lot to say, of course, about the future of all this stuff. But before we get there, I'd like to take a look at the past. It was a while back, Jim, you sent me an email with a link to it was an interview with Tim Cook. Tim Cook, the CEO of Apple. And he was asked why Apple makes phones in China. And he said it wasn't because of cheap labor. China isn't the place to go these days for cheap labor. It's because, I think he said, you could fill several football fields with experts in trades, people who know how to make tools and therefore make quality products. That distinction used to belong to the United States. Now it belongs to China. I'll start off here with Ben. What would you say are the consequences of this shift and maybe overall decline in America's expertise in these important trades?
I think if we start with how the United States acquired a similar capability early on, I think that'll be instructive for us to think about what we've lost in the sense that we don't have anymore and what that has cost us. So initially, after the Civil War, the United States developed more and more capacity, first to invent new types of devices. And a lot of that invention capability was really through artisanal skills, the skills of, building a prototype, oftentimes something that might be difficult to manufacture at scale. And as the world opened up and there was more and more global trade beginning in the 1870s up until the First World War, those artisanal skills were really complemented by the skills of how to take either a drawing or a prototype and figure out how to design a process around it, how to design the tooling to make something at scale. And what I think is really important about how those skills evolved in the United States is they weren't sector specific. So a lot of policy right now and a lot of I would say prescriptive industrial strategy has focused on let's build up the chips industry or let's build up the electric vehicle industry. But how this evolution happened in the United States and also I would say in China was that there was a diverse array of capabilities in terms of tool making and process development, such that you have someone who prided themselves on taking a look at any device and having the ability to make it and figure it out. And it was that type of really shop floor creativity that thrived and allowed American manufacturers to excel in textile making as well as in steel fabrication as well as in bicycle making, et cetera, eventually automotive and aerospace. So what I think we've lost in no longer having those skills, and we can go into why we lost those skills, is really an important capability around innovation. That today the paradigm is that in the United States, you might have the Apple engineer who designs the next version of the iPhone, and then the production engineer who designs the process to make it in China. When that process is decoupled, you essentially might lose the speed of iteration by not having design close to manufacturing. You might actually miss certain things to improve the design and efficiency by not having the process. So what ends up happening, and my colleague Suzanne Berger has documented this, is that the best design engineers end up spending a lot of time on or close to the factory floor. So you one way or another need to have design close to manufacturing, and in a global economy where you've separated the two, you need to have a lot more I would say innovation expertise in a place like China. So what we've lost, I think, is important value-added processes and value-added activities in the United States, and we've lost the speed to iterate and invent in the United States as well. And of course, we've lost very good jobs, which tool makers. And the jobs that really grew in the age of mass production in the United States are no longer here. The average manufacturing worker in 1950, the worker on the factory floor, made 40% more than where they can make elsewhere in the economy. So manufacturing jobs were decidedly good jobs, and today they make only 2% more in the United States than they can make elsewhere. So that wage premium in manufacturing has really disappeared, and that's because we've lost a lot of those skills of how to contribute to invention and innovation.
Well, that's an interesting take, that the idea that it's the factory floor and understanding how things are made actually enable innovation. Like you said, those things have been decoupled, and there may be a misunderstanding, including one that I would say resides inside myself, that innovation resides in the engineering space. And so you take what the clever engineers come up with, hand it over to the factory floor, and then the sort of commodity industry takes over of making that thing. But it's the back and forth between the factory floor and the engineers that enable the innovation in the first place. And Jim, having worked in the automotive industry for several decades, I'm guessing you've seen some of this transition take place. But does that resonate with you, that the connection between the factory floor and design spurs engineering?
Yeah, absolutely. I just, was head nodding all the way as Ben was talking about that challenge because it's been my experience as well. I think also in the lean community, Matt, it's a step that we've kind of skipped over.
Yeah.
We've spent a little bit of time talking about innovation and the front end, and whether we use LPPD or Agile or whatever to create these products. And then, of course, we spend the lion's share of our time in manufacturing, but we rarely talk about knowing how to make things, right? That deep knowledge that process people, tooling people, fixture people understand. And I think that's a huge enabler to making great products, whether it's in automotive or elsewhere. And just based on personal experience, the number of suppliers in this space has rapidly diminished. I think there's a number of reasons for that. Some of it is the difficult times the auto industry has been through. A lot of them weren't funded well enough to survive those times. But it's also been a lack of new people coming into the trades, of apprenticeships. I think there's far fewer apprenticeships than there once were. People are not choosing to go into those trades for whatever reason, and I think that's also contributed to the lack of capacity within the U.S. I don't know if Ben, if that's something that you've looked at, this sort of pipeline of developing new tool makers or model makers, sort of nationwide.
It's the tough thing is it's a bit of a chicken and egg where, like I mentioned, when the wage premium has declined, there's not the wage incentive to get into the industry at an entry level, I would say. Of course, if you're an excellent tool maker, you could demand a high wage in today's manufacturing. So there's a little bit of the wage gap issue. And then there's also the challenge that a lot of large OEMs have become accustomed to acquiring these skills abroad. So there's been this comfortable pattern of global supply chains that have become more and more fixed. What's nice about the last 3 years has been there's a shakeup such that now if you really were in a position in 2021 to say, hey, diversify your supply chain by using me, I'm a domestic manufacturer, you had a really strong case because a lot of OEMs were open to that. But I would say the other challenge here is that a lot of companies have found what they've needed abroad to some extent. And it's unclear, I would say to your original question, Matt, it's like, what have we lost? A lot of it's kind of uncertain. We don't really know what innovation would look like today if we did have the same tool making capabilities that we had 100 years ago. Because I think we've been somewhat maybe satisfied or somewhat complacent about the product cycles that we've been experiencing and how global supply chains have I guess worked until March, April 2020. But I would venture to say that there have been a lot of things that have been broken, but we haven't really been able to recognize as such. So overall, productivity growth in manufacturing has been quite low. In the United States, actually declined in the last 13 years. So there hasn't been enough innovation. And then overall in the U.S. economy, we've been stuck in essentially a productivity dip since 1970, and I would attribute that in large part to the decline of manufacturing as a large, as historically the driver of productivity growth, but because manufacturing has shrunk, it hasn't been able to deliver that boost to American productivity and prosperity overall.
I don't want to spend too much time on China, but you said something earlier, Ben, that got me thinking. This idea that it's the process production capability that enables the innovation. I've been struck recently learning about companies like BYD and their development of vehicles. Frankly, I was shocked when I went on their website and I saw what looked to be pretty awesome looking cars. And it occurred to me that in the not too distant future, people may purchase Chinese brands, not for cost, but for quality and innovation, which is very different than how things have been in the past, where the sort of made in China label was poked fun at. I don't know if you have a sense of this or if it's part of your research, but is that what you're seeing, where China's not just production capability has far surpassed the United States, but do you think innovation is close behind it in terms of capability?
I want to clarify one thing. I do think there's a different kind of innovation that's coming from China, it seems. It seems much more of an incremental innovation or a fast follow innovation, whereas the United States historically has specialized in radical innovation. So a type of company like Tesla, it is, to me, it strikes me as a company that could only have emerged in the United States, given the level of experimentation and the essentially flipping how you would think about a car on its head. Now, what I find remarkable about China, so I haven't heard examples from, let's say, the medical industry where there's been a lot of sourcing from China historically, but still kind of has this made in China problem where it's associated with lower quality goods, but also the most competitive on price. I haven't heard those quality problems going away, but one reason why we might, as America, thinking about American manufacturing, might be concerned that China would exceed American-made products not only on price but quality as well, is that the knowledge base in China is just becoming so dense and so strong. So I guess the lore from Alfred Marshall back in the day in the UK, when saying that the knowledge of an industry was just in the air, that when you walked on the street, just everyone knew about what the language of the industry was, um, how to make important components, how things fit together. That seems to be what is happening in China, particularly around consumer electronics now, where you go to a coffee shop with a drawing and you could find multiple people who would be able to make it for you or knew how to piece together the different parts of the supply chain to make it. So because all that's so local and because that knowledge and shared language is so widely available, I do think it's just a matter of time before that knowledge translates into more rigorous, higher quality process, and just more robust manufacturing overall. The volume is certainly there, and the density of the workforce is certainly there. Now, the advantage that the United States still, I think, has in spades is on research and development and more radical innovation. Then now the question is, if my argument is that we can actually capture downstream benefits of that radical innovation and R&D if we produce more of the prototypes that we're developing in the United States and have them scale up here.
Yeah. Over the past few years, there's been a lot of, you've mentioned it earlier, talks around industrial policy, especially with the infrastructure bill and the CHIPS Act that passed, it's been a couple of years now. There's debate around government's role in influencing industrial, the manufacturing, the industrial sector. And based on your research, what have you seen work when it comes to the government through policy influencing the manufacturing industry?
I'll lay out two perspectives on industrial policy that I think have been the dominant ones, and then I'll suggest a third perspective that I think has the most evidence and the most promise for what you're describing. So the first perspective, and this is kind of from the Reagan administration through to the Clinton administration, was really a market-based perspective on manufacturing. That where the United States has comparative advantage, we should make things in America, but where Japan or South Korea or China has comparative advantage, we owe it to our consumers to buy things from those countries, and we don't need to manufacture them in the United States. We can do other value-added activities like services, like developing software, et cetera. And that was embodied by Larry Summers, in large part, very famous economist and policymaker, who said, we don't really need an industrial policy that supports manufacturing. The market will determine what manufacturing we can do competitively. And I think there's some really a good case to make for this, in large part because you want to have manufacturing companies that can compete, and if they can't compete, you don't necessarily want to prop them up. And the negative example here is that when the Obama administration tried to prop up clean energy companies like Solyndra, and those companies failed, it was quite disastrous for future efforts in industrial policy. So the market case, I think, has a strong backing to it and still has a lot of exponents. However, beginning in the Obama administration and continuing on through Trump and Biden, I think accelerated by the pandemic, there was a second perspective that started to emerge, and we can call that kind of the reshoring perspective, which said for defense reasons, for economic security reasons, and resiliency in response to crisis, we really want to be able to make certain things in the United States and to make them well. Things like medicines and vaccines, products for defense, chips that might be essential for just daily life, not to mention national security. And these critical technologies or critical sectors should be a priority, and we probably even want to subsidize them a little bit, which is the motivation for the CHIPS Act. Now, with chips, I think you can really make this case because just to be on a level playing field with other countries, you kind of need to play ball and offer subsidies, which other major producers tend to do. So I don't have a strong theoretical objection to that. But what I think is missing in this critical technologies approach is this emphasis on innovation and really an understanding of like why why chips production hasn't happened in the United States for so long, and why EV production, battery production hasn't scaled up in the United States. And one of the reasons is that over the last 4 decades, investors and capital markets have been more and more averse to supporting American manufacturers and financing scale up of manufacturing in the United States. So the markets have more and more tended toward capital light businesses that favor a strategy of offshoring, and that's because they're risk averse, right? That producing, having a capital intensive business that fails is a huge hit on your books. So this is all a lead up to say that the industrial policies that have evidence of success, and I think can really make a difference, are policies that help de-risk investments in U.S. manufacturing. So they can recognize that, yes, there's a strategic interest in manufacturing in America, and that really the market forces should play a role in shaping which investments win and which investments lose. But to get over the hump of making that initial scale-up investment, you're probably going to need to de-risk investments in new capital. So there's an example from the EU, which has done this. So there's an EU-wide policy to support new investments in capital equipment for manufacturers. And across multiple studies of this program, they found that it significantly helps businesses. It improves hiring. It has a number of positive downstream benefits for companies. It's really an example of an industrial policy that seems to work. I think what's important there is it's not sector specific. It doesn't try to pick out which technologies are critical and which are not, because if we're honest and humble about it, we don't quite know which technologies are going to be critical for the next innovative wave of one thing or another. And I think we want to be open to new technologies that we couldn't have predicted or identified in advance.
Well, I wonder if part of that an element of risk is the talent pool. What you said earlier around in China, it's in the air. There are just loads of people who are capable of making high quality tools, develop excellent processes. It's almost like a network effect, it sounds like. And so how do you solve that problem where you want to get this off the ground, but for it to be effective, it sounds like you actually need a lot of people all at once to be participating in the exercise. Does that make sense? It seems like it would be how do you solve the problem of not having enough talent when the way to solve it is to have a lot of talent all at once?
It does make sense, and I'd love to get Jim's thoughts on this because he came from Rivian, which is one of these really companies on the frontier that I think is attracting wonderful talent. And what I'm looking for in my research are spin-offs from companies like Rivian, Tesla, SpaceX, exciting manufacturers that are transferring a lot of this knowledge of how to do a new, more digitally intermediated, very innovative and iterative manufacturing. It's training the next generation of manufacturing innovators and experts, both on the factory floor, but also from engineering. So, at MIT, we're focused on, from the manufacturing perspective, selfishly, how do we ensure engineers might go to a manufacturing company or a manufacturing route versus let's say, a more traditional, like a software route, like a Google or Meta. But part of me thinks that might be the wrong question, and that instead, if manufacturing becomes more risk tolerant and starts to do, work on really exciting problems with high growth, like a Rivian, Tesla, SpaceX, then you almost solve the problem yourself because you're exciting enough to attract top talent. That's mostly focused on, I would say, the engineering side of the house. Now, on the other, I would say, more trades-focused side, the question is how would you take someone who is mechanically minded and has the potential to be a really strong tool, who might have been a tool maker in 1900, but that might not see that option today. And there, I think it's the educational infrastructure that today we don't really have. There's no MIT or Carnegie Mellon of the trades that they could go to, have a prestigious. Maybe you could become a really successful entrepreneur as a contractor if you're mechanically minded and make a good living as a plumber. But there needs to be a similar, very clear route onto the factory floor that in most cases doesn't exist. So that's an institution that I think is waiting to be built.
Yeah, I completely agree with that. I think to some extent, sort of this segment of the work has a bit of an image problem. They need to get some better marketing because there is ample opportunity for creativity, for the application of deep and technical knowledge in actually making stuff. And it's incredibly rewarding to sort of start out with a napkin sketch of something, and at the end be able to produce this thing just based on your know-how, your skills that you develop over a year. And what I've found very practically, as we have had the opportunity to introduce engineers into this space in particular, they do get really excited about it. I think it gives a lot of sort of immediate positive feedback that's very different from some of the design work that they're typically involved with. And I think that exposure is a big part of it. At a higher level, I do agree with you that there is a lack of infrastructure to develop these folks starting out. I think many people choose engineering, sort of a 4-year degree approach, as opposed to skilled trades, maybe because of societal factors, right? There's a sense of, hierarchy or whatever that's engaged here. But I don't think that's actually true. And I think some of the most brilliant people I've ever met have been tool makers that can figure out how to make anything. They're some of the best problem solvers I've ever worked with. And they're just brilliant people, even as I mentioned before we got started, serving my own apprenticeship and some of the pretty hardcore journeymen that I worked with at the time, their ability to, sort of trig things out was absolutely amazing. Just sort of, back of the hand calculations that were able to produce these really high precision, tools and fixtures. And I think for me, that's really exciting. And I think it's definitely a missing link in how we think about making great products.
Jim, you have the experience of being both a tool maker and you have a PhD in engineering. How do you think your experience tool making influenced your thinking around product design, engineering during your time at Ford, Rivian?
Yeah, it had a huge impact. This sort of idea of where we ultimately had to make things and what the steps were required to be able, excuse me, to get to the point where we could mass produce something. In fact, I thought it was so important that I made a point of having our engineers visit the tool shop, having our engineers go to the assembly shop, to the stamping plant, because I wanted them to get that hands-on experience, right? That real-time feedback from watching, tool tryout and, launch runs and things like that, because I think it gives you a much better sense of, sort of what you're developing. And I think that's also why having some in-house capability in whatever company you're in, but particularly in auto companies, is so important. Not only to work up front with the designers to be able to develop the art of the possible, right? Just what we can do, from a design perspective, but also to work with the engineers in terms of material selection and, sort of what the limits of each of these materials are in terms of manufacturing. And then, of course, at the launch point where sort of, everything comes together and you enter what Elon Musk famously called manufacturing hell or whatever that was. that's where you really need to have the tool makers sort of, side by side with the engineers solving problems when things don't work out exactly the way they do. And if you think about having to outsource all that, worse yet, having to outsource all that to Asia, let's say, that makes it really difficult to have the sort of iterative relationship that Ben was talking about early. And that's just as important up front as it is downstream at the point of launch. And I think also not having that capability causes you to miss out on possibility of innovation, right? The way we used to work with our process guys and our tooling folks is, rather than just fees rejecting a design, let's talk about what's possible, right? How can we achieve this effect, this characteristic, this whatever it is, in a sort of tool-friendly way? And you need really bright, experienced people to do that. And a lot of that capability, quite frankly, has retired, is gone, is sort of not available today. And I think that's hurt a lot of companies.
Well, I'd like to begin looking ahead at the industry. Ben, you spend a lot of time researching and on the floor at small, medium-sized manufacturing companies. What do you see as the challenges they're facing, and maybe the investments they should be thinking about making? Something that struck me about some of the things that you've written, and it resonates with what we see. I think a lot of people think that you go into a factory in America these days and you see a lot of automation, 3D printing, robotics. That's just not the case. You still see a lot of mostly manual labor. In some cases, I'm guessing the floor hasn't changed in probably a couple of decades. But what do you think manufacturers today should be thinking about looking ahead, say 5 or 10 years?
I think there's certainly a challenge for small and medium companies of taking new risks in order to grow. So if we look at the most fundamental challenge for SMEs, oftentimes they're suppliers into larger OEMs, and they're at the whim of these sometimes fickle companies that if they lose, it's tough to take a risk as a small or medium company to try to double your business if you don't know, whether you're going to have a contract, a year out from one of your biggest customers. So I think a lot of times these SMEs are boxed in by these customer relationships. And really, if we're going to talk about growth and thriving for SMEs, you need to talk about how OEMs support their suppliers and invest in the capabilities of their suppliers. So what I say next is going to sound a little bit like an indictment of SMEs. I don't mean it that way. I mean it as the upgrading the capabilities of SMEs is also going to require support from capital markets and support from OEMs. With that said, capital expenditures, investments in new technology from SMEs just has been flat for quite a long time now, about 2 decades. And robots and other types of automation, as you mentioned, are rare, right? It's the exception, not the rule for SMEs. And I think that comes back to a risk-averse attitude. Why would I invest in a robot or automating these processes if I don't know if I'm going to be running this line in a year, or if I don't know if I can really grow this over time? However, we do know that these investments in technology are critical for companies becoming more competitive in study after study, in geography after geography, from the Netherlands to Canada to the United States. When companies do invest and scale up their automation, they end up hiring more people, they end up more productive, and they end up more profitable. So it's really this frustrating paradox where when companies do make these investments, they end up really successful, but a lot of companies are stuck without making these investments for a variety of constraints. Now, I think for policymakers, but also from I think the LEI perspective, when you can work with companies to figure out, how do I pull back these constraints so that investment in automation makes sense. I think that that's really key. And what you'll notice, I think, is that I didn't really talk about workforce there, and that's been a big theme of the first half of our conversation. I think that once companies do invest in these new technologies, some of the workforce problems begin to take care of themselves. One is that new technologies can help design higher wage jobs. So once you're managing an automated cell, you're able to attract workers at a higher wage. That might even attract workers with more experience and higher skills. It also is just maybe a more interesting and attractive job. So it takes care of some of those brand challenges that Jim was talking about. But overall, I do think that these technology investments are often a first step to growing these manufacturing companies.
Yeah, that was something that struck me when I was reading some of your work, Ben, that investment in technology seems to beget investment in people. Just because there's the practical matter of you need to know how to operate pretty complicated equipment, and therefore you need to train your workforce on it. Absent that urgent need to skill up people to operate your new machines, a lot of companies find it attractive to just, leave things as they are, which is to say, not offer many development opportunities for team members and live with the workforce that they have versus invest in them. Jim, I wanted to ask you about what Ben said about OEMs. You've worked for Ford, Rivian, and you've had the chance to study several of them through your dissertation work and books with like the Toyota production system, Toyota product development system. Do you see a difference? Well, first, was what Ben's saying resonate with your experience inside the automotive world? And do you see examples that where the OEM is working collaboratively with a supplier and that results in that supplier's success where it otherwise would not have existed?
Yeah, not only the supplier success, but the OEM's success by building stronger relationship with key suppliers. I guess a couple things. Not all suppliers are created equal. It depends on the type of relationship that you want to forge with that particular supplier. If it's largely sort of commodity based stuff that you're basically shopping price and whatever, that's a very different relationship than a supplier who's providing you with a key technology, say for your vehicle. Lighting is a really good example of specialized technology where building strong relationships with the supplier is really critical to the OEM in order to be competitive, because it's such a highly specialized commodity that they're creating. So that's an area where you want to build a very strong relationship. You want to develop not only in terms of sort of day-to-day interactions, but we would work hard through our match pair process to develop aligned long-term strategies with those key suppliers and make commitments so that they could make the kind of investments that Ben was talking about that sort of helps everybody. But that takes a lot of work. And if an auto company has hundreds of suppliers, you're not going to do that with everybody. You're going to do that with the key ones and the ones that you think you can rely on. We made a lot of progress with the match pair process at Ford, which I've talked about a number of times, and the kinds of relationships we've developed with our suppliers. But still, I think the benchmark for this is Toyota, and the kinds of strong relationships that they have with their suppliers, the reliability that suppliers have. They're able to rely on Toyota for a continuing relationship, so that they're much less hesitant to make the kinds of investments that are needed to stay competitive and to continue to fuel innovation. The other advantage of that, quite frankly, is then the OEM can be the beneficiary of that innovation. Yeah. And so if you have a long-term relationship with somebody and you've built a true partnership with that supplier, then you're going to get, sort of first opportunity to incorporate that innovation or technology into your product. As opposed to somebody that you deal with sort of with an arm's length shopping for price only kind of thing, where they're much less likely to want to share that with that particular OEM. So those relationships are important, but again, you need to manage them actively because it's it varies from supplier to supplier.
Mm-hmm. I would like to look even further ahead, especially with we were just speaking with the CTO of a software company discussing the consequences of the advent of AI and its rapid development. I don't know if you spend time exploring that, Ben, or if you've seen its use. It's still fairly new, but it is staggering how quickly it's advanced and how broadly it's currently being used. But have you started to see any, I don't know, I hate to use the word disruption, but just use inside of manufacturing companies, or even just initial thoughts of how this new technology could be applied inside of manufacturing companies?
Certainly. So if I take off my manufacturing research hat and put on my, we have a project at MIT on generative AI and its impact on work, which cuts across industries. It includes, healthcare, finance and insurance companies, and manufacturers. This group I co-lead with Kate Kellogg, who's in the business school, and Julie Shaw, who's an aerospace engineer and AI researcher as well. And what we've learned there is that this is focused particularly on the new generative models that have caused a stir, let's say, but not the I would say longer marinating, more narrow AI algorithms that are already in place at a lot of manufacturers that support, in some cases, design or scheduling or other processes that are, I would say, ancillary to core production. But so the short answer to your question is yes, there are manufacturers that we're actively looking at that are trying to integrate these tools into some of their core functions. And the most common one is knowledge management. This is an application for manufacturers as well as services companies. And the use case goes something like this. There's an engineer that has a question from a customer, and typically they would go into the cafeteria and find the right 3 people who could answer some dimension of this question. Aggregated, it might take them a couple days to find all the right people to string together the responses. Then they'll go back to the customer and they'll have a full answer to help solve their problem. What these manufacturing companies are trying to do now is take a lot of the knowledge that's in the heads of those people in the cafeteria that might be buried in drawings or elsewhere in this encyclopedia, or database of documents, design and otherwise, and make it easily accessible and searchable through essentially a generative AI front end. Now, this is a really, I think, interesting challenge. And right now, a lot of the companies have this database of documents already there, but it's not really accessible because Boolean search doesn't quite work for it. But it's interesting, I think, for 2 reasons. One is it could really cut down the time of doing this kind of cafeteria search for different people. But 2 is that it introduces other potential downsides. So one is that these tools, while they're very flexible, they're not terribly reliable. You'll ask it the same question twice in a row and it'll give you a different answer. And then the second, and this goes to some of our earlier conversation, is that we don't really know what we lose by not asking your colleagues and going to the cafeteria, right? You might have learned something in the cafeteria that you didn't expect to learn, but it improves your answer that just by going into this database of documents, you wouldn't. So I'm curious about these trade-offs that we might make in terms of speed versus, let's say, creativity or interpersonal interaction. And this is one thing that is going to be interesting in our ongoing research. But yes, I would say that that mostly large companies are actively developing these applications.
Well, something I found interesting about the conversation we had again with this CTO of a large software company, he said, recently there have been a lot of examples of junior engineers using AI to write code, and it's not particularly good code, but the junior engineers are too junior to know that. And I saw until that conversation, I saw AI as a tremendous tool to really skill up people quickly. But here's a case where it's doing the opposite. The engineer thought they were producing something good and doing it quickly, but because it was doing it for them, they were losing the opportunity to develop the skills to produce something better. And I wonder long term, are we going to offline too much of our brains and our hands to the machine so that what we're all talking about here, skilling up people, uh, it has AI may have the unintended consequence of doing the opposite and stripping ourselves of skills that to think and do for ourselves.
I think that the classic example of AI in our lives is Google Maps. And I think there's this interesting trajectory that early studies of Google Maps showed something called algorithmic aversion, that if you had a habit of going a route, from point A to point B that you were familiar with, and Google Maps told you something that was different than that, you wouldn't trust it, that you would actually doubt the algorithm. You'd go your typical route, even though Google Maps might have given you a faster direction. Now, what we've shifted to, I think, is over trust in the algorithm, because we no longer know how to get from A to B on our own, and the skill of navigation is atrophied. So this is a question. For a lot of people, it's okay to have that skill atrophy, to have navigation commodified on your phone. But I do think that in high stakes scenarios, you might not want to offload that skill to the algorithm, and you might want to control that yourself. So it's interesting. It'll be interesting to see what we choose to commodify and what we continue to control.
Well, also with the topic we're discussing, trades, I can't make anything. I'll be honest. I'm totally useless. Set me back in the 19th century, I'd be 6 feet under fairly quickly, or cast off by my small community because I can't help them with anything. But Jim, you have all these skills, and I have to believe that as a tool maker, as much skill lives in your hands as it lives in your head. You think AI is going to help somebody get somewhere faster, but in the case of trades, I feel like it does have the opportunity to do the opposite more quickly, because if you're not practicing something with your hands and you've offlined your thinking to the machine, where do you go from there?
Yeah, so I think technology has already had, if I understand your question correctly, technology has already had a huge impact on the trades. The CNC machining is a really good example. Some of the scanning capability is just incredible. We've seen with our partners at GE Appliance, and of course, while I was at Ford and even TDM, scanning, 3D scanning is super powerful aid. And so far, the technologies have been an aid to the tool maker. What I'm interested in, and the thing I was thinking about as Ben was talking about Google Maps, is when does AI start to make the decisions, right? So right now, the tool maker is still the decision maker, and the technology is sort of at his service. But I have seen instances where people spend more time in the service of the technology than it does to them. And that's where I start to wonder about sort of where this is heading and what the eventual outcomes are. I mean, I said earlier when we were talking with Fabrice, the software CTO, I sort of approach these things with open-minded skepticism. I'm open-minded in terms of there's tremendous opportunities, right? We've seen it with smart CAD, we've seen it with simulation and testing and things like that. But it isn't always as reliable as it's made out to be. And so I think it's really important to form a hypothesis, and then experiment in small, quick ways to determine the best application of these capabilities within, the particular environment that you're working in, right? Your organization, or what your goals are, as opposed to just sort of buying into the technology vision wholesale without approaching it with critical thought.
Okay. I'll wrap up with one final question. This one for Ben. Just generally, what do you see as the most exciting stuff happening in the manufacturing space right now?
Startup factories, I think, are very exciting. I have in some of my work documented the decline of new manufacturing companies, which is I think a great way of capturing this lack of faith in ability to raise new money or attract new people to make things in America. And that bottomed out in about 2010, 2012. And over the past 15 years or so, we've seen a slight uptick more and more in the rate of new manufacturing companies forming in the United States. And it's no longer, companies that say, oh, I'm going to design a new product, but I'll build it. Once I scale up, I'll build it in Asia. It's companies that say, no, we want to build production infrastructure in the United States. So that's what I'm most excited about, in part because those companies, they're not encumbered by multiple generations of doing things a certain way, and they can often attract younger people who might think a little bit differently, and their trials and errors, I think, will hopefully spill over into the family-owned businesses, to the OEMs, and really, move American manufacturing in some new and exciting directions. So I'm really excited for those companies. If any of them are listening, I'd love to talk. Come visit. It's nothing's more fun, even if I'm more like you, Matt, and can't make things myself. To watch other people make things is really exciting and inspiring. So yeah, it's been great talking to you, Jim, too, about it, because I admire your work and really thankful to be here.
All right, I'll leave it there. Thank you, Jim, and thank you, Ben, for joining me here on the podcast.
And my pleasure.
Thanks.
I'd like to once again thank Ben and Jim for joining me here on the podcast. And of course, thanks to you all for listening. Until next time.